In this lesson, we're going to solve absolute value inequalities. Let's take a look at some examples. We have the absolute value of b is less than 8. So this is two statements here. Okay, this is saying that b is less than 8 or negative b is less than 8. All right, so these are the two statements we have here. However, our first statement, b is less than 8, is fine. Our second statement, negative b is less than 8, we want to alter this. We don't want negative b. This is like negative 1b. We actually want positive b. So if we divide each side by negative 1, we're left here with b dividing by a negative, if you remember. It flips your sign, so now b is greater than negative 8. So now our two statements are b is less than 8 and b is greater than negative 8. So on our number line, we have negative 8 and 8. Our less than signs take our open circles. Here it says b is less than 8 going to the left. This one is b is greater than negative 8 going to the right, and then overlapping here in the middle is now our solution set is between negative 8 and 8. And the values of negative 8 and 8 are not inclusive since we do not have the inequality sign. Another quick strategy for this one here, let's just take this for a second and minimize this. We'll come back to that. Once you have something like this, okay, another quick strategy here is, and what we're going to use in the upcoming problems, is drop your b, less than, greater than, keep your 8, and negative 8. And now we have this all combined in a compound, saying if you read it backwards, b is greater than negative 8, or negative 8 is less than b, and b is less than positive 8. All right, and we'll use this strategy in the next few problems. Okay, same example. Absolute value of x is less than or equal to 5. I'm going to take this value here, and I'm going to drop my x. I'm going to write my sign here and keep it in the same direction. And I'm going to bring my 5 down and my negative 5 on the opposite end. So now when I graph this here, I have negative 5 and 5. And here this is saying, if you read this backwards, x is greater than or equal to negative 5. So we have a closed circle here. Greater than or equal to negative 5, moving to the right. And here on the other side we have x is less than or equal to positive 5. So another closed circle, moving this way to the left. So these two will overlap. So our solution set is between 5 and negative 5, and 5 and negative 5 are inclusive in the set. Let's take a look at another example. A is less than negative 3. All right, so something should be going off here. This is the absolute value of a is less than negative 3. Well, any absolute value always comes out positive. So this is no solution. This is impossible. The absolute value of a cannot be negative 3. Cannot be less than negative 3. Next example. Okay, so now we're going to throw an expression inside. B plus 9, or the absolute value of b plus 9 is less than 15. Okay, many teachers show this in two steps. You can say, okay, once you have something like this, you can say b plus 9 is less than 15, or b plus 9 is greater than negative 15. Okay, flipping sign. That's one strategy. Again, I like the 2-for-1 deal here. So I'm going to take this here and I'm going to just bring down my b plus 9 and leave my signs facing the same direction. And I'm going to bring down my positive 15 and add a negative 15 here in the back. Okay, and I'm going to solve for b. So if you forget about the one side of the equation here for a second, so if we just mentally block out this section here, let's block this out for a second, and just work on this right side here. B plus 9 is less than 15. Well, we would solve this by subtracting 9 from both sides. Okay, but now what I'm going to do is actually do it one more time. So I'm actually going to subtract 9 again from the other side and do it all simultaneously. Okay, so now I have negative 15 minus 9, I get negative 24 is less than b. That simplifies, see you later, is less than, and then 15 minus 9, and I get an answer of 6. So now when I go and graph this on my number line, I have negative 24 and I have 6, both open circles. There is no equal sign here, so both open circles. Reading from left to right, or reading backwards, b is greater than negative 24 going this way. B is less than 6 going this way. So I have an overlap here in the middle. So my solution set is between negative 4 and positive 6 without negative 24 and positive 6 being inclusive. Alright, so block out one section, but you could do the same thing simultaneously and get your solution that way. Let's look at another one. So the absolute value of x divided by 5 is less than 3. Alright, same deal. This whole argument is in the absolute value, so I'm going to bring this down. X over 5 is less than or equal to 3 or greater than or equal to negative 3. Okay, we solve here. I don't want x divided by 5. I want to get rid of this divided by 5, so I'm going to multiply this by 5 to simplify my 5s. But in this case, what I do to one side, I'm going to have to do to both sides here. So I'm going to multiply this side by 5 and multiply this side by 5. So now I have negative 15 is less than or equal to x, which is less than or equal to 15. I'm just going to fix my x here, put it more towards the middle. Alright, and that takes care of that, except for our number line. Let's plot this one now. So we got negative 15, positive 15. We have less than or equal to, so close circle, and my number set is, again, all my solutions are going to be in this. This is greater than negative 15, this is less than negative 15, everything overlapping in between these two, and being negative 15 and 15 inclusive. Okay, absolute value of 8m is greater than 40. Absolute value of 8m is greater than 40. So again, I'm going to start with my middle term, 8m greater than 40 or less than negative 40. Okay, it's a little different in this one. Going to divide both sides by 8, all sides by 8. So I have negative 5 greater than m, which is greater than positive 5. So let's see what happens here. So we have a negative 5 and a 5. This is saying m is less than negative 5, not inclusive. Being less than negative 5 is going to the left. Here it says m is greater than 5, not inclusive, going to the right. So now we have our solution set between the opposite ends. So our solutions are from all my negative infinity, or all my negative numbers, all the way up to negative 5, or very close to negative 5, and then all my positive numbers from 5 or greater, not including 5 or negative 5. Alright, so now we have a two-step equation side. So we have 7b, the absolute value of 7b plus 9 is greater than 19. So here I'm going to drop my absolute value. So 7b plus 9 is greater than 19 or less than negative 19. Okay, I'm going to subtract 9 from both sides. Okay, negative 19 minus 9, they're both negative. We're going to add these two here, so I'm going to have an answer of negative 28 is greater than 7b. These go away, which is greater than 19 minus 9, and I get an answer of 10. Okay, I'm getting closer. I don't want 7b, so I'm going to divide all sides by 7. Alright, and here I have negative 28 divided by 7. I get negative 4 is greater than b, which is greater than 10 over 7. Can't be reduced. I'm just going to leave it as 10 over 7. Alright, got a number line here. Negative 4, and I'm just going to leave this as 10/7, which is fine. Less than, no equality sign, so open circles. B is less than negative 4, so going to the left. B is greater than 10/7, going to the right. Some teachers actually like when you draw right on the number line, but it's your preference. Okay, a couple more examples here. We have 3x plus 7 is greater than 11. Alright, so again, 3x plus 7 is greater than or equal to 11 or less than or equal to negative 11. Alright, so another two-step equation, so minus 7 from both sides. Okay, here we got negative 18 is greater than or equal to 3x. See you later. Greater than or equal to 11 minus 7, we get 4. Okay, what's next? Divide by 3. So we have negative 6 is less than or equal to x greater than or equal to 4/3. Let's plot this on our number line here. Just going to bring this up a little bit. Okay, and we have negative 6, 4/3, close circles, x is less than negative 6, going that way, x is greater than or equal to 4/3, going that way. Next example. 10 times the absolute value of 4n is less than 80. Okay, so if you notice here, the 10 is outside the absolute value sign, so being that it's attached to this implies multiplication. So let's clear out everything before the absolute value. So we want to isolate the absolute value. So we want to get this absolute value here all by itself. Okay. All right. So let's divide both sides by 10 here. This goes away. So now I have the absolute value of 4n is less than 8. All right. So we want to get to this point here. Once we get to this point here, we're going to say, okay, can the absolute value of 4n be less than 8? Sure. It could be 7, 6, 5, 4, all the way down to 1. Okay, it can't be less than 0. All right, so here's my part where I split this up. I can say 4n is less than 8 or greater than negative 8 on both sides. Divide both sides by 4. And here I have negative 2 is less than n, which is less than 2. All right, piece of cake. So open circles at negative 2 and 2. Open, open. N is greater than negative 2, going this way. N is less than 2, going this way. Overlapping. So our solution set is between negative 2 and 2 without either number being inclusive. Okay, next example. We got negative 20 times the absolute value of 5n is greater than 40. Our first line of attack is isolating this absolute value by getting it by itself. So let's do that. Let's divide by negative 20. Divide this side by negative 20. All right, remember when you divide by a negative, you're good if you're thinking, this sign has to flip. So rather than being greater than, it's now going to be less than. And negative 20 goes into 40, negative 2 times. All right, so now we have the absolute value of 5n is less than negative 2. So if you're thinking something's going on here, you're absolutely right. Can the absolute value be less than a negative number? Absolutely not. So in this case, no solution. The absolute value of 5n cannot be less than negative 2. All right, so once you isolate your absolute value, look at your statement. Make sure your statement is true. Make sure your statement can happen. The absolute value of a number cannot be less than any negative number, or less than 0 for that matter. Next example. Absolute value of x minus n plus 9 is greater than 16. All right, so now it's not attached through multiplication. I'm actually adding 9 to the absolute value. Again, my first line of attack here is to isolate the absolute value first. So let's get rid of this 9 from both sides. So now here I have the absolute value of x minus 9. My 9's go away, is greater than 7. Okay, can this be greater than 7? Can the absolute value be greater than 7? Absolutely. So here we have x minus 9 is greater than 7 or less than negative 7. Solve this one-step equation, plus 9 on both sides. All right, so we have 2 is greater than x, which is greater than 16. Beautiful. Let's bring down our absolute value, our number line. So here we have 2 and 16. Open circle on both. Let me bring this up a little bit here. Okay, open circle on both of these. It says x is less than 2, going this way. X is greater than 16, going this way. So any solution less than 2 works. Up to and not including 2, any solution for 16 or greater also works, and so on. Alright, so here we have 3 times the absolute value of b plus 10 minus 8 is less than or equal to negative 11. Alright, so we have more going on here. We're actually multiplying and subtracting. And this might be a red light to some of you guys where you see, okay, this is less than negative 8, and you're saying at this point, well, you can't have anything less than negative 8, than a negative number, which is normally true. However, until you have isolated the absolute value, so until you get this absolute value by itself on one side, do not make that assumption. So let's do that first. Let's get this absolute value on one side all by itself. So this is the same as something like if you have 3x minus 8 is equal to negative 11. Your first step you would do is add 8 to both sides. Well, same attack here. I'm going to add 8 to both sides first. Okay, so bringing everything down, so I have 3 times the absolute value of b plus 10. That goes away. It's less than or equal to negative 8 plus, negative 11 plus 8 is negative 3. Then I'm going to divide by 3. Divide by 3. Okay, so here now I have the absolute value of b plus 10 is less than or equal to negative 1. And now, at this step, now that we have isolated the absolute value, now we can look at this and say, is this possible? Can the absolute value be less than or equal to negative 1? Okay, now we can say, no, it cannot be less than a negative number. This is a no solution. So not until we get to that piece there, that we've isolated the absolute value, can we make that assumption. And we'll see a couple more examples where it will work. Right, so here we have negative 10 minus 8 times the absolute value of negative 5x plus 6 greater than negative 42. Alright, so I'm going to add 10 to both sides here. Okay, this goes away, so I now have negative 8 times the absolute value of negative 5x plus 6 is greater than negative 42 plus 10. I get an answer of negative 32. Alright. Let's get rid of the negative 8 here, so I'm going to divide by negative 8. Alright, so again I'm dividing by a negative number, so let's not forget to flip our sign here. So I have the absolute value of negative 5x plus 6, flipping my sign, is now less than, and negative 32 divided by negative 8 is now positive 4. Now let's look at this argument and say, can the absolute value be less than 4? Absolutely. It can be less than 4 up to 0 or up to 0 in a sense, okay? Not including 0. So now let's solve this. Now let's bring this back into our two steps here. So say negative 5x plus 6 is less than 4 or greater than negative 4, setting it up. Alright, so now we have two-step equation, minus 6 from both sides. Alright, so we got negative 10 is less than negative 5x. That goes away. Less than 4 minus 6, negative 2. Alright, getting closer. Divide by negative 5. Okay, be careful. I'm dividing by a negative again. Dividing all sides by a negative. So now here I want to negative 5 divided by negative 10 divided by negative 5. I get positive 2 divided by a negative. Now this sign flips, simplifies, x, flips, and negative 2 over negative 5, which simply we'll just say is 2/5. So now I'm reading this as x is 2 is greater than x, or x is less than 2, and x is greater than 2/5. So if we want to draw a number line here, I'll draw it here on the side. So we have 2/5 and 2. Open circle on 2/5, open circle on 2. X is less than 2, greater than 2/5. So greater than 2/5, less than 2. Many times the proper way of writing this correctly would be to have the smaller number on the left. So we could say 2/5, x is greater than 2/5 and less than 2. This would be the better notation. The smaller number being to the left, bigger number being to the right, just like a number line here, right? As your numbers increase on the number line, 1, 2, 3, 4, 5, and so on. All right, so let's get used to that as well. All right, I believe I have 1 or 2 more examples. All right, so here we have negative 4 times the absolute value of negative 7n minus 6 plus 8 greater than negative 32. Okay, let's move through this one. Same as last one, negative 8 minus 8 from both sides. So I got negative 4 times the absolute value of negative 7n minus 6, see you later, is greater than negative 32 minus 8, we get 24. divide both sides by -4. Divide both sides by -4. My 4 is simplified here, and now I have the absolute value of -7n minus 6. Flipping my sign is less than -6. Okay, nothing, and there isn't any absolute value that can be less than a negative number here. So now we can say n is a no solution here. Okay, so not until we get to this point where the absolute value is isolated without any numbers being multiplied or added to it or divided by it, then here we have n is, then we could make the assumption that it's not. All right. Let's go for this one. So subtracting 10 from both sides. All right, here we got 7 times the absolute value of 1 minus 4b is greater than or equal to -105. Divide both sides by 7. So now we have the absolute value of 1 minus 4b is greater than or equal to, and then we have 7 goes into, now this is a negative divided by positive. Before you even figure out what this is going to equal, you know the answer is going to be negative. So, and it's going to go in there 3 times, so 5 times, negative 15 times, so it's going to be negative. So absolute value greater than or equal to -15. That can happen, okay? It can be greater than or equal to -15. So just because this is negative, look at the inequality here. Can it be equal to -15? No. Can it be greater than -15? In this case, it can be. So let's take a look at this one. Can this happen? And this one could be a little tricky, right? So let's see what can happen here. Your solution is going to have a domain or a number that b has to be greater than or less than to make this work. So let's say if we try to play this out, let's say 1 minus 4b is greater than or equal to -15 or less than or equal to +15, like we've been approaching the other problems. All right, so we're going to subtract 1 from both sides. We're going to get 14 is greater than or equal to -4b, which is greater than or equal to -16. Okay, here we're going to divide by a -4. Okay, dividing by a negative. So this is going to be here -7/2 simplified is less than or equal to b, which is less than or equal to 4. Alright, so then we have our number line here. This is saying that b is going to be greater than or equal to -7/2, closed circle, less than 4, also closed circle, less than or equal to 4, and our solution set will be in here. One last quick example, and just to go back to one of the ones we did before, we had an example where it was being divided, and I just want to point out a quick little difference here. Okay, if you have the absolute value of b over 4 is greater than or equal to 5 versus absolute value of b over 4 greater than or equal to 5. Notice here the 4 and the b are both inside the absolute value, where here the 4 is not. Alright, so here is one of the examples where you would clear the 4 first and then say, okay, now you have the absolute value of b is greater than or equal to 20. Where here you would just go right into the breakup and say, okay, b over 4 is greater than or equal to 5 or less than or equal to -5 because this is in the absolute value.